So now in this video we're going to look at the LM358 op amp. It's an operational amplifier made for single supplies. You can also use it with dual supply though, but single supply means there's a positive side of the power supply and a negative side, which is called ground. A dual supply or split supply is when ground is a middle point between positive and negative, but we won't worry about that now. So there's one op amp on the left side there, one op amp on the right side. We're going to look at the one on the left. The basic property of the op amp is the output voltage depends on the voltages at the inverting input, the negative there, and the non-inverting input, the positive. And if they are unequal, if the non-inverting input voltage is higher than the inverting input voltage, the output will be high. It'll output directly from the positive supply right there. If the non-inverting input voltage is lower than the inverting input voltage, then the output will be low. It'll be connected to ground internally like that, as good as it can get. The LM358 goes to ground better than it goes to the positive supply, but that's the basic premise of this circuit. Here we have the start of the breadboard example. So we got this resistor to the negative supply, that resistor to the positive supply. They're equal value resistors. We are going to power the breadboard with 5 volts, so that'll give us 2.5 volts right there. Of course we have the power pins powered where I showed you earlier. So now we add a trim pot coming to the non-inverting input right there. And these inputs, by the way, just look at voltage. They don't depend on current, just a very speck of current trickles through, but practically none. In any case, we're coming to the wiper. The trim pot, we have a variable voltage, so that's our reference voltage. It's a fixed voltage, and this one we can go higher all the way up to 5 volts there, and then down to 2.5 where we set there. And while we're higher, the output will be high, and while we're lower, the output will be low right there. So I already covered trim pots before. I'm going to keep this quick, so we'll move on. And so now I have the pocket oscilloscope measuring the output up there, the top pin. The voltage divider here, our trim pot, is set all the way to a negative. So hopefully you can see that. I'll zoom back just in case. Now if I turn it up halfway, you're going to see a sudden change in voltage at the output right there. And so it doesn't matter how far I go as long as it's above halfway right there. And it doesn't matter how low I go as long as it's below halfway there. One thing you'll notice is it's a 5 volt power supply. Without a load, the output for this op amp can go all the way to ground. Not all of them can. If you're sinking current though from a load, it will throw it off. But no matter how hard you try, all you're going to get out of 5 volts is looks like 4 volts there. Again, that's with no load. Load will throw it off even more. And finally, flashing LEDs are nice. So if you've seen my other videos, I got it wired so the blue LED lights up when the output's low. You can see the line lead the anode to the positive supply there. The red LED I have to light when the output is high. You can see the short lead the cathode to ground right there. And so the other side of the power supply has to be the other side of the power supply coming out of the output, as close as it can get. It's going to fall short both directions here. So in any case, hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen. Click like, subscribe, the bell, all that. Donate to Patreon if you can. That helps out the most. But just watching videos helps out a ton. Thanks for watching them. I'll see you in the next video.